Good afternoon and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen and I'm the program manager for the center and will serve as your moderator today. We would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series, and Lisa Ruggiero and Laura Flagg of the National Recycling Coalition for assisting the RMC with webinar promotion and technical support. Today's webinar focus is on agricultural plastics recycling. Our presenters today are Lois Levitan and Scott Coleman, who I will introduce in a moment. Following the presentations, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you are experiencing technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on both the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And now I'd like to introduce our presenters. Lois Levitan is a Senior Extension Associate in the Department of Communication at Cornell University and works on special projects in the areas of environment, health, and risk. In the early 2000s, she founded the Recycling Agricultural Plastics Program, also known as RAP, to tackle the multiple hurdles in the way of viable and sustainable recycling of waste plastics from agriculture. In recent years, her interests have expanded to include other difficult to recycle plastics. Scott Coleman is Vice President of the Strategic Development of Delta Plastics, a position he has held since August of 2013. Scott is responsible for driving company growth through organizational development, mergers and acquisitions, financial planning and analysis, product development, new market entry, and business optimization. Okay, Lois, you're on first, so you can get started.
Okay, thank you very much, Wayne. So just to expand a bit on what Wayne said about the program, I'll just tell you that RAP began a bit more than 10 years ago, and it evolved from concerns that a few citizen activists brought to Cornell University's Center for the Environment about the health and environmental impacts of burning plastic and open fires on farms and in backyards. So this got me started looking into recycling as an alternative to open burning. And my initial poking around eventually morphed into what became this program, which has taken on a life of its own. Over these years, we've learned a great deal about what are generally considered to be difficult to recycle plastics. But I've got to tell you, by no means do we have all the answers or even a program that is as successful as we would like it to be. However, we've gained a pretty good handle on what the issues are. We've put together lots of resources and can even offer some pointers on getting around typical constraints. Like if you were faced with a pile that looked like that, that would be a problem. What was on the slide there. But be forewarned, I'm not going to be able to provide a cookie-cutter model for how to operate a recycling program for agricultural plastics. There isn't such a model because what works in one place won't necessarily work in another. Among other things, there are very significant differences among the plastics used in different sectors of agriculture, which I'll be going into, as well as differences in access to compaction and processing equipment, in proximity to markets, and certainly in regulatory environments. So moving on, I'd like to acknowledge the team with deep gratitude, the friends and colleagues I've worked with on this issue over the years. In my home turf of New York State, I would particularly like to acknowledge the three people who have in sequence held the position of RAP Senior Field Coordinator, David Cox, Blake Putman, and for a number of years now, Nate Leonard, who is on the right hand of the slide. And also the staff of local agencies and organizations across New York State who have partnered with RAP to talk with farmers about recycling and collect their plastics. And the other folks in this picture are some of those people. Further afield, a small crew of what I'm calling agricultural plastic recycling champions has kept in touch since about the mid-2000s, batting around ideas and collaborating on organizing conferences and workshops to try to move agricultural plastics recycling from a concept to at least a partial reality. By talking to each other about what works and what doesn't, we've learned more, pushed the envelope further, and had more fun by being in this together. And so I thank you all. There's now an opportunity for others, for example, those of you who are participating in this webinar, to join the cadre of, quote, agricultural plastic recycling champions. Jean Jones, who's organizer of the annual Agricultural Plastics Recycling Conference and Trade Show shown in the slide here, and I are hoping to kick off an agricultural plastics stewardship stakeholder association at the gathering this summer for the conference. We'll be having some initial organizing meetings. So the conference itself promises to be invaluable for networking and a chance to delve deeper than I could possibly do in this webinar. But the purpose of the stakeholder group is to have a means for building and maintaining those networks between conferences. So I encourage you to look into the conference and consider joining the stakeholder group as it gets moving. Going back to the webinar right now, my objectives are threefold. I want to give an overview, which I've organized along the life cycle of agricultural plastics as indicated in this schematic, but also speaking primarily from the perspective of what we've learned in New York State and elsewhere. My objective is also to be very specific and pragmatic about what we found to be important, what we think is possible, what does not seem to be working, and why. And my third objective, and this is not in particular order of priority, is to point you to resources to follow up and go beyond what we will have time to talk about today. I'll be referencing a lot of material that's posted on RAP's new website, and you should be seeing a screenshot of that right here. So I want to give a heads up that this website is the place to go for more information, and more will be posted in the coming weeks and months. In addition to the main content pages, over here in the sidebar on top is a slideshow of products made with recycled content, mostly content from recycled agricultural plastics. And below that is a list of listing of events. Contributions to this website are welcome, particularly information that you may have about recycling markets, compaction equipment, and events. So please be in touch if you have such information. We're going to start with the use of plastics on the farm. So the topic of agricultural plastics stewardship engages two groups whose paths might not otherwise cross: agricultural communities and recycling communities. Since this Sustainable Materials Management webinar series is organized by and primarily for the recycling materials management community, I'm going to start with an agricultural plastics 101 and show what materials we're talking about. Most of the plastics used in agriculture are made primarily from one of four resins. Each resin has specific characteristics, such as strength and stretch, that make it the most suitable for the product it's being used for. Going from left to right in this matrix, there's high-density polyethylene, HDPE, and that's used primarily for containers, pesticide containers, dairy sanitizing containers, and pots for plants. Linear low and low density polyethylene are flexible. Chemically speaking, they're branching, which gives them this flexibility, and they're used for films and tubing. Together, these polyethylenes, and there's also, this is a simplification, there's a whole family of polyethylenes. Together, they are the most prevalent of plastic resins that are used. Polypropylene is used for big bags that are often called super sacks, as well as for twine. And polystyrene is used primarily for seedling plug trays. We still see some polyvinyl chloride, PVC, in the mix, coming primarily from drainage pipes that are thrown in with the rest of the ag plastics pulled out of the field, old maple tubing, and some of the imported drip tape and irrigation tubing. I'm now going to fairly quickly breeze through some slides that show what the products look like. To see these and other photos at your own pace, take a look at the presentation entitled Agricultural Plastics in Pictures that's posted to the RAP website. The main point I want to get across with these slides is that agricultural plastics include a number of different products. Some rigid, some flexible, made by different resins, by different processes, and in different colors. These factors, as well as the thickness of the films, are some of what matters to recyclers. Let me just go back here for a minute. This irrigation polytube is the main product coming out of Scott's Delta Plastics company. And this picture is actually from Delta Plastics. So as I say, you can see those slides and the information on them in the presentation, Agricultural Plastics in Pictures. So in addition to the differences that I've already mentioned, many products are made with a mix of resins or with additives that give specific technical properties that optimize agricultural production. For example, these could be additives that enhance or block transmission of UV light, or they create a gas impermeable barrier to prevent spoilage of animal feed or the volatilization of fumigation chemicals. So that's this EVOH-O2 barrier. Or they add a reinforcing scrim to a sheet of plain polyethylene film, throwing in an incompatible material, polyester, nylon, cotton, in with polyethylene plastic. While the additives enhance agriculture, and hence that's why farmers will purchase them, they can be a challenge for recyclers. So when someone says that they have, quote, agricultural plastics to recycle, or that, quote, they recycle agricultural plastics, more questions need to be asked to have clear communication between the farmers supplying the used plastic and the recyclers who hope to process it. Simply referring to ag plastics tends to muddy the waters and frustrate everyone. The fact sheet, Agricultural Plastic Products, which includes the table shown here, goes into more depth about the characteristics of these products and what makes them more or less appealing to recyclers. Some of the things I've just been mentioning. Recyclers are usually quite particular about the kinds of plastics, in other words, which plastic resins they will accept for processing. And this is for several reasons. The cost of acquiring material differ, the cost of processing it differ. They will have, different recyclers will have different capabilities and limitations of their equipment. And finished products are made with a recipe that calls for certain plastics that give the products the desired characteristics. So that's why recyclers aren't going to just take all ag plastics and really need to be more specific. So because of this, it's a plus for farmers and the organizers of recycling programs to be able to differentiate among common plastic resins so that the sorting and separating can happen at the point of collection. For example, a sink float test can be conducted in the field that will differentiate plastics of most interest to recyclers from those that cannot easily be recycled. And this decision tree on the left shows that. The only equipment that's needed for this test is a jar of water, at least for the water test, and then a jar of alcohol and a jar of oil for the other tests. With the water test, only the polyolefins, which are polypropylene and the polyethylenes, will float in water because they're less dense than water, as can be seen from the table on the right. While other tests and observations are needed to refine the identification of resins. The sink flow test alone will enable segregation of PVC, which can sneak into the mix, as I mentioned a little earlier, in old products that are being replaced, as well as in some of the imported products. Most recycling plants are not set up to handle the toxic emissions from PVC, so most recyclers are adamant that PVC not be in the mix. The fact sheet identifying common plastics in agriculture, which is also on the website, includes both these decision charts, the density chart shown here, and also describes several simple tests and observations that can differentiate plastic resins. So the separation is really pretty important and is one of several basic best management practices, or BMPs, that we've been encouraging producers, agricultural producers, to integrate into their normal agricultural production process. In New York State, where burning agricultural plastics was permitted, entirely legal until a few years ago, normalizing the recycling BMP sometimes requires massive changes in attitudes and behaviors. So we found that it's critical to teach, repeat, remind, and insist on BMPs before making any commitment to collect plastic. This we found can be an uphill battle, but one made easier where there is an enforced government mandate to recycle, as is the case in most countries in Europe, or when the standards are set by an engaged and committed recycling market, such as Delta Plastics, as you'll be hearing later, that offers incentives and has a system for tracking used plastics back to its source. So the basic BMPs for storing plastic after it's no longer in use are to keep the plastic as clean, dry, and free of pebbles and clumps of soil as possible, to cut and fold plastic into pillow-sized bundles, store it off the ground out of mud, grit, and gravel, and separate stored plastic by color and product type. To elaborate a bit more, we found it's important to communicate the standards to the staff who actually handle the plastic, as well as to the boss. I think it's important to convey that the standards are reasonable and attainable, not pie in the sky. And these days we've found that it's important to focus on the need to eliminate grit, gravel, and garbage mixed in with the plastic, and reduce the anxieties that can come when people think that the plastic needs to be completely clean and unstained, which is not the case. If possible, have quality control at the point of collection and reject plastic that does not meet these standards. Again, if possible, create the incentive of accepting recyclable plastic for free, but charging a garbage tipping fee for plastic rejected when it doesn't meet the standards. Be able to track the plastic back to where it was used with some form of labeling, which I go into it in more detail elsewhere. And one more thing, older lists of BMPs, both from RAP and also from other sources, would recommend rolling film into pillow or pallet-sized bundles. However, RAP's Nate Leonard noticed that it was better to fold rather than roll bulky film into bundles, as shown over here on the right. These are folded bundles. These are rolled bundles. Because the folded bundles stack better, as shown here. And when the stacked pillows or bundles are kept under the weight of a pallet, air is forced out. So in fact, the stack begins to compress, reducing the space needed to store the material, and also shortening the amount of time it takes to bale the material when a baler then becomes available. Our experience has also shown us that best management practices for bale wrap are a little different. Bale wrap is the most flexible of the plastics used to wrap animal feed. About 3 to 3.5 pounds of wrap is used for each individually wrapped bale, and perhaps 2 pounds per bale when the bales are in a line and the ends are not also wrapped for each of the bales. That was what was shown in the opening slide. The film is wrapped around the bale multiple times. One time I counted and videoed it, it was 54 times that the bale spun around. So most of the plastic touches neither the hay nor the ground. It's only in contact with other layers of plastic. What this means is that most of that plastic is pretty clean. So if it's immediately shaken out and rolled into a bundle as soon as it comes off the bale, it will be clean enough to recycle even without washing. The Canadian company Think Plastics made its baleboard lumber from unwashed bale wrap, as did Rubber Sidewalks, who manufactured TerraWalk sidewalk pavers, both of which came out of the process with a pleasant gray color. The trick is in storing the used bale wrap somewhere where it will stay clean. The corner of a barn is shown in the bottom right picture, is one example. Another option is to put the bundles in big bags, as shown on the top of the slide. These big bags that are variously called flexible intermediate bulk containers, or FIBCs, or sometimes called flexible totes or super sacks. When it's in these bags, bundles of bale wrap stay clean and contained. And because the FIBCs have been coming into increased use for storing all sorts of materials, taking the place of many other kinds of containers, they are relatively easy to access. In fact, WRAP has been collecting totes from distributors of commodities such as beans and birdseed and providing them to farmers who use bale wrap, which is a truly win-win situation because it had been costing the bean distributors about 50 cents per bag in tipping fees to throw away their old bags. And it would cost people who wanted to use the bags about $3 to buy them used, and going up to $20 to buy them new. So everybody was happy with this arrangement. We had hoped that these polypropylene bags could eventually go into the mix of plastic to be recycled, but I've heard from processors that the simple solution may not work. The reasons are that some of the commodities that were initially stored in the bags leave a residue that's corrosive to recycling equipment. That would be the case if there was sugar in the bag, for example. And the straps on the totes, look at the arrow on the slide, are typically made from a material that's incompatible to recycle with polypropylene. I would be very interested in hearing from anyone who is successfully processing these totes for recycling, because most of that material is really an excellent polypropylene for recycling. We also learned from some hard experience that pest management standards continue to be important after plastic is baled. It's not enough to keep the material clean up until the point of baling. Afterwards is also important. Gravel is absolutely ruinous from recycling equipment. So good plastic can be made unusable if the pile of loose plastic or finished bales are stored directly on grit or gravel that's common in many facilities. Many yards outside of trucking facilities and the like are often have a gravel base because of drainage, but it is ruinous for the plastic. And moisture itself is not a contaminant for plastic that will be washed, but it nevertheless is a problem if the plastic stays moist, because grit and gravel adhere better to moist surfaces than dry surfaces. So it's best to keep the plastic awaiting baling as well as finished bales under cover of a roof or a tarp. These and other points are covered on the webpage, Guidelines for Storing Bales of Plastic Awaiting Shipment to Market, at the RAP website. Moving on to the next part of the life cycle flow chart, when and how to move waste plastic from the farm and where it goes next. So this will depend somewhat on the size of a particular farm operation, but for the most part it depends on variables that are beyond the control of agricultural producers or the organizers of agricultural recycling programs. The two major issues that I'm going to touch on, there's much more to say, are in criteria for selecting a centralized collection and storage site, and then secondly, the pros and cons, advantages and disadvantages of compacting plastic on farms versus transporting it loose to a central location for baling. The deal is that most recycling markets want full loads, full tractor trailer loads of 40,000 pounds or more. In most cases, that means that plastic from small and mid-sized farms must be consolidated at a storage location while this threshold weight is being amassed. And in many places, to find a location sufficiently close to farms, but collecting from small farms, this process can take a year or more to fill a full tractor trailer load. You may be surprised, as I was, how difficult it can be to find a suitable storage location. Places where one might expect to find a loading dock don't necessarily have one. And places with a loading dock and the equipment and personnel to load a truck may not have adequate space or may not be permitted to store accumulating loads of plastic. Especially with these constraints, I found it was helpful to have a list of criteria for the kind of place we were looking for. So here's what RAP Experience suggests. Take advantage of the experience of local MRF and transfer station managers for advice and suggestions. Ask about using their facilities and equipment. Then also check out places like farm supply distribution centers. Ideally, the collection site will be centrally located for farmers and others who will be delivering the plastic, but sufficiently out of the way or access restricted so as not to attract attention or invite anonymous drop-offs. It's best if restricted access sites have staff who understand the quality standards and can therefore knowledgeably accept or reject the delivered material. The site should have room for several very large piles of plastic, if the plastic will be delivered loose, and should have room for at least 60 finished bales. I'm thinking here of 40-inch cubes, in order to accommodate material of different types that may need to be shipped to different markets. The site should have sufficient space so that bales don't need to be moved time and again to accommodate other stored materials, which can cause the bales to fail. There should be a flat, dry surface, either a concrete pad or a packed earth barn floor. And if there's a chance that the ground will get wet, or if the ground surface is gravel or gritty, in other words, if it's not a flat, dry surface, a supply of pallets is needed to keep the plastic off the ground. But roof cover is not necessary. It's good because it will keep the plastic out of sun, rain, and snow, but it's not necessary. The bales can be outdoors. Ideally, there will be scales to weigh the plastic upon delivery, which is important information to have when loading the truck. The weight of individual bales will indicate whether the bales are sufficiently dense. Again, quite important. Now, the caveat is that this weight will include the soil, moisture, and debris that are considered contaminants, so it's not a final net weight. But by weighing loads at this point and then after the plastic is processed, you'll be able to track contamination levels of different types of plastic from different sources, have a baseline, and then be able to track improvements. Very importantly, a loading dock or loading ramp, which is shown in this slide, the loading dock is shown in this slide, and equipment such as the skid steer in the center of the slide with forks. These are needed to load bales into an enclosed trailer, maneuver the bales within the trailer, and stack the bales too high. It is possible, we've heard, I don't think we've actually done it, to load a trailer without a loading dock or ramp, with just having a skid steer and forklift with a pallet jack, but it makes for a much tougher job and probably less efficient loading. And equipment isn't enough. There also must be staff or contract labor available to operate the equipment. You will need permission to store the bales for the duration of time needed to amass the full tractor trailer load, which, as I said, could be a year or more. Some otherwise ideal locations, such as transfer stations, are often restricted in how long recyclables can remain on site. And they may also have limited hours when they're open for pickups that don't jive with the hours when a trucker is going to arrive. In New York State, storage sites must be registered with the New York State Department of Environmental Conservation as a waste management facility, or the site must have a permit for these purposes. And there may be similar requirements in other states. These are not a big hurdle, but you should know about them. The guidelines that are referenced here elaborate on these points and also on the best type of long-distance transport vehicle to request, pros and cons of loading bales of plastic on pallets into the truck. Some truckers do not want pallets on their truck, and some insist on it. The procedure for loading the bales and the importance of labeling for tracking material. Under almost all circumstances, plastic has to be in bales or in compact rolls before it can be loaded into a tractor trailer for long-distance transport. But before getting to when and where to compact plastic, let me convince any doubters why to compact plastic. It's simply that loose plastic takes up a lot of space and is prohibitively expensive to transport. This slide compares the load weight of baled plastics, shown over here, versus a load of plastic bale wrap stuffed into totes, shown here, and a load of silage film that's been cut into strips, folded, and stacked, but not baled. The bottom line is, as you can see from these calculations, unless the distance to be traveled is very short, it's simply not cost-effective to transport plastic that isn't rolled or baled into a compact form. Now, when I'm saying rolled, what I mean is using a roller so that you have a round end product, dense end product, rather than a square or rectangular one. So we're aiming at getting a 40,000-pound load into the tractor trailer. That's what the markets want. And you can do this quite easily with 40 to 50,000 pound bales. We found that the totes typically hold about 200 pounds of bale wrap. A very diligent tote filler who jumps on the bale wrap and really pushes it in there can get more, but experience has shown that this is what typically comes in, about 200 pounds of bale wrap, and that about 80 bags will fill up a trailer van. So that means that the capacity of a van filled with totes is not going to be any greater than 16,000 pounds. And in fact, experience has shown that it tends to be less. And that is very disturbing for the person paying for transportation. And then we found that when the bulkier plastic is folded into these pillows, stacked and weighted down, as I described earlier, each pallet will hold about 350 pounds of plastic. So that means that 3 pallets of plastic that's stacked but not baled is the equivalent weight to one finished bale. So again, 16,000 pounds of this plastic would fill the trailer van. Chuck Sparks, who was formerly at the helm of Think Plastics, where baleboard lumber was manufactured, developed a system whereby farmers dropped loose plastic at one of the several dozen MRFs in southern Ontario, Canada. And Think Plastic staff would pick it up from there using a garbage truck compactor with a grapple at the front end. Chuck found that this system, which did not require baling, was cost-effective and worked well for his program, but only within a 200-mile radius of his plant. And I haven't even shown here the weight of loose, fluffy plastic stuffed into a trailer van, because I really don't know how much could fit into the trailer van. But anecdotally speaking, when we were gathering plastic for the first baling demonstration back in 2006, we found that it took 12 pickup truck loads of loose plastic from a local farm to make one 1,000-pound bale of plastic. While this is hardly firm science, it suggests that each pickup load held about 85 pounds of plastic. Just 85 times 12 is about 1,000. So it makes sense to partially compress the plastic leaving a farm by stuffing it into totes and folding it and compressing it in a stack, or doing something even for short distances, but then baling for long distances. Some recycling markets have designed other systems, such as the Think Plastic system I just mentioned, But unless a recycling program has made arrangements with such a market, it's smart to assume that the plastic should be baled. Now to move on to the question of at what point in the process should compaction take place. I think there are several advantages to compacting plastic on the farm, and we'll mention those first. When there's no mandate to recycle, farmers may simply not be willing to bring plastic to a central collection point. So the reality is that on-farm collections can increase the capture rate. Pilot programs that were done early on where farmers were asked to bring in plastic had very, very low capture rates and were not successful. On-farm baling can also be an opportunity to meet farm staff, educate about best management practices, and do on-the-spot quality control and make suggestions for improvement. So on-farm baling can reduce the farmer's costs in both time and money, as well as the environmental costs of transporting loose plastic to a central collection point. However, on the other hand, on-farm compaction equipment can be expensive to purchase and maintain. Use of the machine by farmers, we found, was very difficult or impossible to ensure. And depending on who is transporting the baler, can be very expensive to move it from farm to farm. Moreover, at this point in time, there are limited options for off-the-shelf, commercially vetted mobile compaction equipment that can be used on the farm. So even though I recommend it in many circumstances, there aren't very many options for where to find the equipment. Some homemade balers can do the job and are doing the job, but they lack safety features. And many of those homemade balers are retrofitted from commonly available, relatively inexpensive vertical stroke cardboard or tobacco leaf compactors. But cardboard and tobacco don't have the rebound energy of plastic, so balers designed for these materials, the cardboard or tobacco leaves, don't typically have the oomph needed to make a sufficiently dense bale of plastic. Soft bales just don't hold up very well and may fall apart while in storage, and certainly are at risk of falling apart when they're moved. A rule of thumb based on the simple arithmetic of dividing 1,000-pound bales made by a Bigfoot baler by the 36 to 37 cubic feet in the bale is that a nice dense bale will be 27 pounds per cubic foot. That's something really to keep in mind in considering baling options, and obviously that number can you can come up with that number with some simple arithmetic. There's a lot more to say on the topic of compaction equipment, but we really don't have the time to go into it now. So I encourage anyone who's interested to check out the compaction equipment tab on the RAP website. And I ask that anyone who has information about mobile compaction equipment, either rollers or balers that would be suited for agricultural plastics, to please be in touch so this information can be vetted and shared. So far we've covered use of plastic on farms and moving it off the farm, but even at this point, it's far from being recycled. I want to make sure we're on the same page when we talk about recycling. I consider it a multi-stage process that begins by collecting discarded plastic from farms, but that's just the first step, and then goes through some reclamation processes that may be more or less extensive depending on the end product. The reclamation takes the plastic from whole cloth, so to speak, its original form, to make it into small pieces that are ready to use in making new products. This process form could be powder, pellets, shreds, or chips. The old plastic is finally recycled only when something new has been made from it. And in this something new, I do include oil, waxes, fuels, but taking it from what it was before to something new. You might find it interesting and informative to hear about a couple of the collection and reclamation systems that are found in Europe. Start first with Daily Plastic CEDO and CETO, I guess it's not, doesn't even have a next name to it. So colleagues in Europe, where recycling of agricultural plastics is mandated in many, if not all the countries, tell me that agricultural plastics recycling systems in most countries require that small and mid-sized farms deliver their waste plastic to recycling centers or their centralized collection spots, but they'll conduct on-farm collection from large farms. My understanding is that for the most part, plastic brought from the field is processed into granulate or pellets that is then sold either on the open market or to a manufacturer affiliated with a processor. So, for example, as in this slide, Daily Plastics, a company based in the Netherlands, collects farm plastics in much of Europe, does some of the reclamation at its subsidiary corrodopolymer processing facility that's also in the Netherlands, and works hand in glove with CETO Plastics, which processes the remainder into bags that are marketed as household disposables. And they use both their own label and also private local labels as shown in the wrapped plastic on the right. So CETO Plastics does both reclamation and marketing of end products. Another thing I've learned about the systems in most European countries is that they have a national organization that coordinates the agricultural film collection program, something that we certainly do not have in the United States. For example, in the Andalusia region of southern Spain that's shown in this slide, where use of agricultural films is the most concentrated in all of Europe, with greenhouses literally blanketing some of the region, as you can see in this slide. So the top slide was one I took from the road going by the greenhouses, and the photo to the right I took out of an airplane window. It's quite an amazing sight to see. They have a government-sanctioned membership organization of farmers in Andalusia. It's called Ciclo Agro, which coordinates a mandatory recycling program that covers both mulch film, that comes for the most part in a more western part of the province, and also this greenhouse. The greenhouse covers shown here, which are mostly in the subregion called Almeria. This program has a 75% capture rate, including mulch film and as well as the greenhouse covers that go to recycling, and somewhat larger capture rate that also considers the material that they're not able to recycle. So some factors that contribute to this rate of success include that the material is homogeneous. It's either going to be mulch film or greenhouse tunnel covers. The law, which mandates that farmers clean, sort, provide temporary storage, and deliver to recyclers. The existence of the organization, Ciclo Agro itself. It's a membership organization of 20 of the largest producers in the region. And they provide a means of collective communication between the agricultural and recycling communities, and see to a standardized process for moving used plastic from the field to recycling facilities. So the system that's used for the greenhouse covers is that they are put in large bins just outside the greenhouse structure. And these bins are either collected by recyclers or brought to one of the 5 plastic recycling processors who competitively bid on the material and are located within an hour or two of the agricultural production facilities. And this is possible both because of geography and the infrastructure. In most parts of the United States, we can't duplicate these conditions, though we can aspire to some of them. For example, I already mentioned more than once, I think, our goal of establishing a stakeholder association that could potentially become a trade group comparable to some of the European model. And if successful, this association will facilitate, encourage, and improve on communications between suppliers of used plastics, in other words, the agricultural community and recycling programs, and the processing and manufacturing markets. In my experience, though, potential markets for agricultural plastics come and go for any number of reasons. Scott will probably be elaborating on some of these reasons. Over the years, I've built up a directory of both potential and proven markets, but I have not made it public, partly because they come and go, partly because markets that work in one area of the country do not want plastic from other areas of the country. The transportation is just too expensive. And also, as I mentioned before, markets that handle one kind of plastic may very well not be interested in other kinds of plastic. So I have not publicized this database. Meanwhile, More Recycling Associates has built an impressive database of markets for all sorts of plastics, with much of the gathered information made public on their plasticsmarkets.org website. However, I found that plasticmarkets.org has not had the kind of detail that we've gone over in this webinar. So it isn't really useful for connecting suppliers of agricultural plastics to the potential processors. Thus, I've been working really closely with More Recycling Associates to merge our databases, the results of which should be publicly available within a few months. So rather than my going into details about markets, which we don't have time to do anyway, I'm just going to refer you to plasticmarkets.org. And I will now turn the presentation over to Scott Coleman, Vice President for Strategic Development at Delta Plastics, which is one of the most long-standing, reputable, far-reaching, and viable recycling markets for agricultural plastics. And he will both tell the Delta story and also tell from the marketers, or from the recyclers' perspective, why the situation has its complexities. Thanks a lot, Scott.
Definitely. Well, thank you, Lois. Thank you, Wayne. Thank you, everybody, for being on today. I can tell you quickly about Delta Plastics and our history. We've been around for about 20 years, and we're primarily engaged in the manufacturing of polytube irrigation equipment. And so polytube is a polyethylene irrigation tubing that is used throughout the United States to furrow irrigate and flood irrigate, and primarily in our markets in kind of the Mississippi Delta region. The Delta Plastics, started with this technology, but soon found through years that we had a problem, or farmers soon had a problem, and they accumulated plastic waste, and it piled up on their farms. They would bury it, they would burn it, especially in rural areas where they don't have landfill access, or they're underserved by waste disposal. They had issues, and Delta Plastics saw that was an issue and sought to address it as from a sustainability perspective and also as a customer service perspective. And so over the last 20 years, we've developed a system of collection and recycling of the used plastic that we generate, and it has. I think that the people at the company can definitely attest that it is not without its challenges, and it requires a great team and has required a lot of effort and trial and error and blood, sweat, and tears to get to where we are at today. I think that as Lois addressed, there's a huge logistics challenge. There's a huge contamination and training of farmers challenge. Processing and segregation of materials is a large challenge, and then there's also a market challenge. As we see with recyclers in general, you have fixed costs in collection and processing, but when it comes to the market, the market is usually variable. So that often results in a disastrous outcome for many recyclers. Fortunately for us, this is not our core business. Recycling is not, and manufacturing is where we make our money, and on the sales side. But what we found is that especially say in dipping resin markets as we are today, that no one in the market is willing to pay what it costs to create a recycled product. And but I think that one thing that we've tried to do is try to create a greater demand for recycled products in the market. We have a sister company called Revolution Bag, which takes our recycled resins and makes those into a post-consumer recycled trash bag that is used throughout the United States in hospitals and universities and hotels and in the janitorial market, which kind of creates a steadier output. But there's kind of a misalignment or a misperception that recycled should be cheaper, and currently in today's market, most people will pay less, and that's very troublesome for recycle. Someone trying to recycle ag plastic. I think the other big challenge that we face with this is that for most farmers, they view this problem as quite small, and for each farmer individually, it is a small problem. It's a little bit of plastic. It's temporary. It's only happens for a few weeks a year in a lot of cases. And if you look at their list of priorities and their list of priorities to stay in business, and you look for the recycling of ag plastics or proper disposal of ag plastics, or going through all of the best management practices that Lois outlined, this is probably, if not last, is very low on the list, and that's a challenge that we face day in and day out. In addition to that, if you flip to the other side of the coin and you ask the farmer if you can help, I think their first question is, how much will you pay me for my used plastic? And I think we all operate in our own self-interest, but the reality is that it's a difficult business with the markets. It's a difficult business with all the best management practices, and I think if you look at the market for, say, plastic scrap, and you add up all of the logistics and best management practice costs, all that it takes to package that plastic up and put it on a truck, and the question is, how much is the cost of that truck? It's the summation of all the logistics and baling costs plus the broker's fee, and that's what you're getting. And there's not a lot of room for margin in the business, and so I think. But that said, we are very optimistic that through technology and the progress that we've made, both from a collection, that there's a heightened interest from farmers and farm groups, and especially as you move as farm groups move closer to the retail chain, that there's a heightened interest to make sure that farms are sustainable, that the resources that we use are being taken care of properly, and that we found a lot of people throughout the country from coast to coast reaching out to us asking for ways to help improve or even participate in programs that would improve their sustainability. And that said, we've kind of expanded our reach somewhat, both to California and the upper Midwest, as far as working with farms and other ag plastics users of how to better implement these programs and process this in a sustainable manner. So I think there are a lot of changes underfoot and advancements in that area, which are encouraging. But that said, Delta Plastics I think we're the largest in the United States. I'm not sure across the globe, but we found success at it and in kind of our own unique way, and are continue to be optimistic about the ability to process plastic in the future.
Okay, thank you, Lois and Scott. At this point, we're going to be fielding some questions from the audience. Again, if you have a question, please enter them on the GoToWebinar dialog box. And we do have some questions already. And this one was for Lois. you mentioned the sink float test. This person says the alcohol needed to separate the PE and PP. The ethanol has to be between 35 and 50%. And he also said that alcohols like rubbing alcohol does not work because it has a high isopropyl alcohol content. So you just wanted to add that to the anybody who wants to do a sink float test out there.
That's great. Thanks. If this person could send me those details in writing, I'd love it. And we'll add it to the list.
All right, here's another one for Lois. It has to do with the collection and baling. Could you clarify the 16,000 pounds fits on a 40-foot trailer or a 53-foot trailer? I guess that's the loose or stacked.
Yeah, I was purposely vague. The guidelines actually suggest that when you're trying to access a truck, you ask for the 53-foot van rather than the shorter one, especially if you don't have dense plastic. What we found is that with dense bales, it reaches the transport limit when the truck is about 3/4 full, so it gives you some flexibility, and might even have to move things around so that it's distributed over the different axles per regulations. If you're trying to ship bags of totes full of bale wrap, for example, which is not dense, it really makes a lot of sense to go for as large a truck as possible, not to use the flatbed, like, for example, the picture I showed, just so you can see what the totes look like, shows a flatbed. But with a flatbed, you can't get to a second layer, either of bales or of bags. So an enclosed tractor trailer is much, much preferable, and the 53-foot, when possible, is a better idea. And of course, those calculations. I mean, those are rule of thumb, back of the envelope kind of calculations. You're going to find things a little differently how you go. But the idea is that other than shipping in very compact rolls or in bales, it's not going to be cost effective to transport it.
Okay, follow up to that, Scott. I noticed on your slide, you had a picture of your truck there. What's a typical weight of that load? I guess it's a rolled bale, and it's loaded by a grapple.
The advantage that we have is that we operate in a fairly condensed area, but I think to Lois's point, if it's a loose material, 10 to 15 to 20,000 pounds is probably the most that you're going to get on the load. So we can do some shorter runs, but that type of condensing is essential in trying to get a full load.
Here's another question for you, Scott. I'm not sure if you want to answer this, but does Delta Plastics lose money by recycling ag plastic?
Do we lose money by, I would say no, because if we didn't offer the service, we couldn't make money by selling plastic. So it's part of our closed loop business that we offer. So I'm not sure how we could take it away from our manufacturing side.
Okay, this question comes from Spain. They have this person represents a company that converts ag plastics into oil, and he says it's not considered recycling. And the question is, do you have any thoughts on plastics to oil or energy, plastics to energy type applications?
I sure do. I think it's a part of the system that we want to consider. I don't know who the caller is from Spain, but I wonder if it's one of the one in Andalusia. There are ag plastic materials, such as the twine that's used in Spain, in southern Spain, where I showed you the other pictures from, that's used to tie up tomato vines. And it's absolutely impossible to separate that twine from the vines. Material like that, I think plastics to oil is a wonderful option. My question has long been, is it the answer for agricultural plastics? And I have hoped that it would be since I first learned about it maybe in 2008, and I'm still waiting. I've spoken to probably a dozen different companies, looked into them, vetted them, tried to get them located in the U.S., and I've yet to find one that says, yes, we are successful in recycling agricultural plastics of a quality that is most likely to come to them. I mean, you're not going to send greenhouse covers or dairy wrap, for the most part, to a plastics to oil facility because there are higher and better uses for it. But the materials that are highly contaminated, mixed with debris, mixed resins, increasingly we're seeing polyethylene sheeting, and I showed some slides of this when I was quickly going through the different products, that have a scrim embedded into the plastic sheeting. And so that makes it virtually impossible for your standard recycler to use. Maybe we'll have markets developing that can handle that kind of material, but it couldn't be sold on the open market as a polyethylene because it has this polyester mixed in, or nylon mixed in, or cotton mixed in. So that's the kind of thing that's absolutely ideal, I think, for plastics to oil. So I really hope it succeeds.
Okay, thank you. This is back to a collection question. Can you convert a baler used for wool for ag plastics? And also, what was the cost of the portable baler that you showed on the screen?
Well, I know that the Bigfoot baler, which is the one that I have experience with and showed, has also been used for wool. I don't really know much about baling wool and whether a wool baler would work for ag plastics. I think it's worth trying. And if someone wanted to know about the characteristics that we have found to be important in balers, again, I'll refer you to the website because there's just an awful lot of material up there that both explains how to use a Bigfoot and critiques the Bigfoot and other balers, or give me a call separately to go through and what those criteria are. It's certainly worth looking at. When we purchased the Bigfoot balers, and they were still, I would consider in retrospect, in prototype form, I'm trying to remember what it cost. It goes back a number of years now. But I think that Kenco is selling the balers that it will custom make upon demand for about $35,000. And that kind of price tag is a huge amount to some farmers and not too much to others. So, I won't pass judgment either way. But the approach that we were taking is looking into having a collective multi-county use of the baler that I was hoping could be rented out to farmers, and because of insurance reasons that just didn't work out that way. But I think that a private sector ownership of the baler with lease arrangements, sort of the way that you rent, other equipment through Taylor Rental and places like that, would work successfully for a baler. So I think that at this point they're being sold in the vicinity of $35,000.
Okay, thanks. Back to the burning. Well, it's actually a different type of burning. The burning on the farm. Lois, can you provide any insight on, is that practice safe? What are the issues with just burning on the farm?
Okay, of course, this is where we started. At least my involvement in this issue started. People often say, well, polyethylene is just a long string of carbon and hydrogen. What's the matter with burning that? So when we were initially looking into this, our team included a combustion engineer who surveyed the literature. And she found that it's the temperature of the burn more than the contents of what is being burned that will influence the emission. And most fires on farms will smolder, and it's at that smoldering temperature that dioxins and furans, about the most toxic emissions known, are produced. And they require chlorine. So people say, well, where's the chlorine coming from? It's not in the plastic, it's just carbon and hydrogen. Well, there is enough chlorine in the air and in the soil, to say nothing of fluorinated water, that it can be pulled out and mix with the other chemicals and make that dioxins and furans. In addition, and a study was done by USDA in the mid-90s showing that in the United States, the pathway of most significance for dioxins entering the body of people was through our food chain. So if you're going to have an open fire on a farm and the emissions fall on animal feed or on animals themselves, or on fields where human food is going to be planted, that enters it back into the cycle of getting into human beings. And then more than just the dioxins and furans, the particulate matter has effects on stroke, heart attack, etc. So those are the issues of the air quality, water quality issues that led to this being of concern to the environmental agencies.
Okay. This question has to do with, is anybody moving towards reuse rather than recycling? Are suppliers creating more programs for take-backs, for example, the super sacks or any other type of ag plastics?
Well, we were pretty thrilled to develop our own little take-back program around the super sacks, and then I was disappointed when I realized, and I hope it's not the end of the story, that they're hard to recycle themselves. So that was our own little sideshow that we try to encourage others to get involved with also. There are take-back programs, but they're not reuse programs. Several of the manufacturers, including Delta, of course, what Scott described is one kind of a take-back program. But others have them also. Blackmore, East Jordan Plastics, both of them producers of different kinds of pots for the nursery trade. They do take-back programs, and they give discounts. I'll call it that because I don't really know what the terms of trade are right now, but they do have discounts of some sort that reduce the cost for getting new material. So those take-back programs are operated by a number of manufacturers. As I say, Delta is an excellent example of that. Reuse, on the other hand, it opens up a different trajectory. I've looked into it somewhat. For example, if you buy a higher mill meaning the thickness, plastic for drip tape, it's less likely to rip if it's pulled up on a coil and laid out again. And that, of course, increases handling costs for the farm. So, there's advantages and disadvantages. So that's one thing where people have been thinking about reuse. The plastic that's used on as bale wrap, for example, cannot be reused, because of the way it's fed on, automated on a machine, as shown in the very first slide that I showed. Bunker covers, one of the reasons that they're going towards the reinforced material that has the scrim, which creates its own problems, is that with reinforcement, that plastic can be used for longer. But for the most part, it can't be reused. Oh, one other thing I'll say, greenhouse covers. Some, I'm calling them greenhouses, but in fact some of them are greenhouses, some hoop houses, some high tunnels. There are some production systems that cut the plastic in the spring for aeration and so it doesn't get too hot on the inside. Obviously that can't be reused, but others are keeping the plastic on for longer. There have been improvements in the technology of the plastic production, even since the time that I've been looking into all of this, where more of linear low density polyethylene is being used, which is a stronger plastic, so they're able to use a thinner version of the plastic, and they're able to use it longer before the plastic turns brittle and falls apart. So that's not exactly reuse, but it's longer use.
I found out from Pennsylvania, I found out there's a couple nurseries that do accept pots, and they have a little place where they clean them and sterilize them and reuse them internally. And that particular nursery had said that they reduced their purchase of new containers by 15% a year. So I think that's a good success story. And I also found out that Lois accepts the pots that they sell at their garden centers, and I believe they work with their vendors to take back those pots. I'm not sure if they get recycled or reused. So that's interesting also.
Yeah, let me make a couple of comments on that if I could. You know, the same way that the person asked Scott if Delta lost money on recycling, and his answer put it into the whole system. I think that's a lot of what motivates places that take back nursery pots. I don't think you could find a consumer group who's more eager and inclined to recycle than your home gardeners and your landscapers. You know, this is a prime recycling audience, but it's surprisingly difficult to be able to handle that, because as you know, you look around, you see, oh, these pots are of all different shapes and sizes. I didn't include in this presentation some very funny slides I have that I took at a pot recycling event, where it took about 40 staff and volunteer hours, we calculated, to load a fairly small van, carrying the pots back and forth, putting them on the van, because they don't easily fit together. And then we said, well, maybe it'll be more efficient if we put them into the baler. But once you've compacted these pots, they're going to include the grit and gravel that many of us gardeners put on the bottom of our pots. One of my reclaimers found a crescent wrench in between two pots, so that quality control is absolutely essential. So it has to be integrated into, the quality control has to be integrated into that collection system. One of our local nurseries also did a cleaning program, and they didn't find that it saved them money so much as, which it did a little bit, but the big thing was that they could keep staff on rather than laying them off during the slow season, because they kept them busy sterilizing the pots. I learned after I visited, interviewed, and videoed this going on that the pesticide label on the sterilizer that they were using had changed, and so they should have been wearing full hazmat suits and weren't. So that's something that people need to look into, what the pesticide label on the sterilizer says, and make sure they're in compliance. That's just one of the many hurdles when you actually try to get something done.
Okay, we're just about out of time. There's a bunch of questions here that we didn't get to. I apologize for not getting them, so maybe we can do some follow-up emails and so forth. But I will pose one more question for Lois, and this has to do with extended producer responsibility. I know that some of the ag container recycling organizations do have a model like that. Could you comment on something like that, perhaps for film and other types of ag plastics?
I love the ACRC, the Ag Container Recycling Council, and I love their model, and I wish it would work. But there are a number of reasons that it isn't easily transferable. One of them, if you think about it, is that pesticides are a regulated commodity. Plastics are not. So the push that the manufacturers and distributors of the pesticides that go into plastic containers, the push that they felt with fear, I'll call it that, or concern that they might be regulated externally, prompted the forming of ACRC. There's no such push happening in the plastic realm. In addition, you know, as I've spent a lot of this webinar saying, there are so many different kinds of ag plastics, and there's a lot of different producers, of manufacturers of these plastic products. It's a global market, and in many cases, the plastics used for agriculture are just a small side thing going on in very, very large plastic manufacturing companies. So the company itself doesn't have a vested interest in getting involved in extended producer responsibility. That isn't across the board. There are several producers I've worked very closely with who are eager to see recycling systems come into play. But one other thing, and the specific numbers I'm going to use, money numbers I'm going to use, go back probably about not quite 10 years, but several years. But I was talking to Ron Perkins, who's head of ACRC, and he estimated that it cost about, I forget if he said 40 or 50 cents a pound to actually carry out the recycling of pesticide containers. And that money comes from several places. It comes from the producers of the plastic containers. Well, for the most part, that's where it's coming from. And then they also are selling it to recycling markets. And then there's a better market for high-density polyethylene than there is for low-density. So the money that sustained their program came from those two sources. They also had more money because their capture rate is low. So if I put out 5 pounds of plastic into the market and I'm paying the system, say, 20 cents a pound, but only one of those pounds comes back in recycling, then I have $1 to recycle that pound of plastic. But if I were getting 40, 60, 80% capture rate, I would no longer have that flex. Also, if you look at the value of a pesticide product and pesticide container, that 50 cents to recycle is a small percentage of the total cost of that pesticide product. But if you look at 50 cents a pound, let's just say that that's the cost to recycle a pound of film plastic, that is going to be half, maybe, of the value of the film itself. So these various factors make ACRC an inspiration, but not an easily extrapolated model.
Okay, great. We're actually out of time, so again, I apologize for not getting to all the questions. Lois and Scott will see those questions on our attendee report, so maybe they can follow up responding if they could. So we're going to close the webinar. Thank you again, Lois and Scott. Those are great presentations. Again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thanks again for joining us. We hope you'll join us for next month's webinar, and please visit the NRC and RMC websites for schedule updates. And have a great day, everybody.
Thank you.
Thank you.